Good morning, one and all. This month we are going to see about the topic called as histogram, which comes under data analytics subjects. So, what is actually histogram is? A histogram is most commonly used graph, which actually shows the frequency distributions, and it looks very much like a normal graph, and with some moderations or deviations compared to the normal graph here. In other words, we can say this histogram is mainly used for data visualization, and we have a large amount of data which has to be represented in a graph format, and it will be in a continuous form, not like a normal graph. So that's the difference between a normal chart graph, bar graph, and the histogram. And in one point is it will represent data interpretation of numerical data, which shows number of data points, and it falls within a specific range of values, which we named it as a bin. And I already told the main difference between the vertical bar chart and this histogram is it will be in a continuous form. The graph will not be separated. The bar will not be separated. It will be in a continuous form. So here is an example for this histogram. You can see here how the data can be varied in x-axis as well as in y-axis, and there is no gap between the bars. So next comes is the parts of a histogram. So we have how many parts is we have the title, we have x-axis, and we have y-axis, and we will mention about the bars. We know this already, what is a title, which describes what information we have in that particular graph, and x-axis, which represents the intervals, which shows the scale of values, that is the measurements, and y-axis is how many number of times the value has been occurred, which shows in y-axis, and the bar represents the values occurred within the particular interval. So if, for example, if we have the continuous interval between all the bars, means we will have the same across we will have the same width across the all the bars here. And the next is why we need histogram. Why we actually create histogram is if we have a large amount of data, we normally use histogram here to represent the frequency of the data values. And here we can also mention the median and distribution of the data, which can also be determined by the histogram. And in addition, it will show the outliers of the graph also of the data, or if we have any gaps, it will show like that. And what are all the distributions of histogram we have? We have three distributions, that is a normal distribution, a bimodal distribution, and we have right skewed distribution, and we have left skewed distribution. We will see one by one. What is actually a normal distribution is points on one side of the average will look like same on the other side of the other side of the average. And bimodal is nothing but we have two peaks here. One is the data should be separated and analyzed part should be separated, which here we have shown. And what is actually right skewed is we will name it as a positively skewed distribution, and if it is a left skewed distribution, means it is a negatively skewed distribution. And normally how a right skewed will be is it usually occurs where the data has the range boundary on the right side of the histogram. For example, the data boundary should be 100, and if it is a left skewed, a large number of data values occur on the right side. The opposite will happen here. If it is left skewed, the data will be large in the right side, and if it is a right skewed, the data will be more in the left side. So this is the diagram represents left skewed and right skewed. And here is an example of a histogram. See, you can see the question here. Jeff is the branch manager at the local bank. Actually, the customer, what they have complained is the waiting time of the customers are more high for providing customer service. So how it Jeff has to identify at what time period or at what time of intervals the customers are waiting too long. So here is the representation, and they have mentioned the waiting time in seconds also. See, this is the customer waiting time, which is represented in histogram. See, we have no gap between each bars, and he identified like there are 3 customers in the range 35 1 to 35, and we have 5 customers from 1 to 40, 1 to 45, and 1 to 50, and 2 customers waiting between 1 and 55 seconds. So at last he conclude that majority of the customers are waiting in between these time intervals, that is 35 seconds to 50 seconds. These many peoples are or customers are waiting for customer service. So that's all about histogram here, which is an important topic in important topic in data analytics.